a lot about SAP, so let me point the first question to you, Paolo. Tell us a little bit more about Trenitalia and what you guys do. Obviously, you're a railroad company, but maybe a little bit more detail.
Yes. Trenitalia is a public company, then like in many other European countries, they are owned by the government. We are 32,000 people, and we have an incoming each year of 5.5 billion of euro a year. Then in the recent past, we have been a very big renovation because in Italy there was the first and the only at the moment case of competition on high-speed market. That is that different society, different company run train same tracks in direct competition like the airplane. This is not happen in every other part of Italy. Then we need to build a new conscious to renovate completely the process and the mind of people. And just to say some number, in 2006, Trenitalia lose about 1 million of euro, 1 billion of euro, and now we are gaining 500 million of euro. And we have 55,000 people, now we are 32,000 people, and we operate more train than in the past. Then will be efficiency, increase efficiency is really possible.
So Paolo, by the way, I love the video. I think the video gives away the story so well. Let's try to give some more colors and details. One of the elements that I found personally very interesting in the video, and also with other people always impressive, is this notion of saving up to 10% or 8 to 10% of the maintenance costs. I just want to add one element out of what you say. Trenitalia is already actually one of the best performers in terms of how maintenance is operated today. So I want to make clear, we're not talking about having a very cumbersome process that is wasting a lot of resources and streamlining. We're talking about starting from a very efficient process, a starting point, and moving to the next level. Can you give us some more details around how this huge saving is going to be realized?
Yes, I say before that now we are facing competition every day, and there is more and more competition. Also with the other transport mode, with the high-speed network, we stole traffic from airplane in the range of 500, 600 kilometers. You have to think that in Roma, Milan, in 2006, the share of the airplane was 70%, now is 30%. That is that practically people take train to go from Roma to Milan and then along Italy. But speaking about maintenance cost, in effect, 8–10% is a big figure. But we think also to have good value in reducing failure during operation and then increasing comfort for our passenger, and also to do the same traffic with less train because we increase also availability. Then how we can do this? In this moment, we use the classical approach for maintenance, corrective and preventive maintenance. We saw in the past the limit of this. Of course, corrective maintenance means that you have to support, to have the faults in a commercial operation. Then with some problem of rescue in line with 3 hours stop along the line, then some very good spot for the company. And but what we see is that we do so many controls, safety control, that lead to nothing found, like the indication of the check engine of the professor. And other things is that we are a poor wear measurement of our components. our indicator up to now are also time and distance, kilometer in Italian, or mileage in USA. Then we can have some example that this is goes opposite to the good condition. For instance, if you refer to a door of a train, practically maintenance on a door actually is proportional to distance. But indeed, if you consider the wear of the doors, a good indicator could be the opening, closing cycle, of course. But we have the paradox that if we do more kilometers, like high-speed train, they do less stops and then less opening, closing cycle. If we do more stop and then you do less kilometers, then you do more opening cycle. But in the maintenance plane, for the maintenance plane, actually you do less maintenance when you would need more. And then with this paradox, we have to overcome this paradox, simply not triggering maintenance on kilometers base, but only on some more real indicator that are more representative of the wear of the different component. And of course, could be, it's very hard and complex because it's an individual action for every component. But there is another dimension. Italy is not so big like United States, but we have Sicily that is 40 degrees, and we have also train running in the Alps, on the border of the Swiss and Austria, and then there is -20. There are trains that run continuously. We have, for instance, a fleet of 700 locomotives that they do train from 5 to 10 coaches. Some one run at 160 kilometers per hour for a long time. Some other do very frequent stops. Then you understand easily that average speed, for instance, go from 80 to 120. And then there is so big dispersion of the value that, but we actually make maintenance exactly in the same way. And this is, I say often that we have a treasure on the train because we can save many operations, many spare parts. And there's not also a problem of safety because we don't remove safety barriers that are on the train. We want only that the safety barrier does not intervene. And then we have 3 streams that we use. The first is to collect data from every process data that is produced by the train. A train is very complex. In this locomotive, for instance, we are fetching 5,000 signals each second just to have informations. And with this device, we can also make a remote monitoring on the fleet and then to control if there are some loss of redundancy and so on, and then anticipate the reparation just not to exploit in a good way the redundancy that we have on the train. Then we are projecting some robotic system and the laser scanner system to make three-dimensional modeling of the train every time that the train comes into the shops. And then for that, we make a continuous comparison from historical profile of the train, and for that we can sense some things that now are only controlled by the human. But we need at the moment to move the train in a particular location, and that usually, as like people, we go to take the trains, not the train that come home like a taxi. And then also moving a train inside a maintenance shop is difficult. Then we want that when the train enter into the maintenance shop, already is doing a check-in with the particular measurement that we can do from inside the train, like the wheel, and the pantograph or the profile of the train in general, the brakes, the shoes, and so on. And with this data, we can save a big time of the train. And then we can use for more time a train than in the past. Then the third activity is to mix this very big amount of information in in an analytical system like SAP HANA, and then we triggered maintenance not on kilometer basis, but on some new health and life indicator base. But to do that, as Mr. Gismondi says, we need to manage 700 terabytes a year. And this is impressive figures. It's a real big data. How you think to manage, Francesco?
Yeah, so maybe first of all, I want to explain why we have these very large amounts of data in the system, because as a little bit Professor Kaplan said before, in the past, most of the assets were actually generating data using sensors when certain conditions were met, right? Diagnostic events of pre-identified faults, you can call DTC, DTS, whatever. But basically, you have sensors on board of the machine, there's a computer or some sort of logic on board of the machine. That computer has pre-identified rules. A rule is violated, like, temperature of sensor X goes above 75 degrees. Event is triggered, data is collected. While this actually, even Trenitalia this approach provided pretty significant results. Now we're actually moving to the next level, what we believe is the future, specifically everything related to Internet of Things. This means that we're recording and we're transmitting and storing natively all the signals generated by the train. Some of these locomotives have thousands of sensors on board. We do not record necessarily everything at 1 second frequency because, like, for example, temperature doesn't necessarily make sense to record every second. In some cases, we could go sub-second even. But the amounts are very large. And we know, we discussed many times, we know perfectly well that out of this 700 terabytes per year, probably 90% of this data we'll never use. But the fact is that we don't know which is the 10% that has real information inside. So the only way to find that 10% and to extract this additional insight, this additional knowledge using methods like machine learning, as described before, is to have the full availability of data. That, of course, introduces also a number of interesting technology challenges, because there are out there companies like Google, Facebook, or Yahoo maybe, that have been managing these kind of volumes for quite some times now. It is not bread and butter for normal businesses like ours. I can say I'm personally not aware of many SAP customers running those kind of volumes in their data center. So we actually had to somehow figure out a specific infrastructure and a specific way of managing the data for this project. SAP HANA has been mentioned. Of course, SAP HANA is the key analytical component for this system, but the data are not stored. This kind of data are not stored on SAP HANA. But rather we use another layer with SAP IQ. In the future, we're considering using components like Hadoop, for example, but there's a master storage component, and then the need of making this data available for high performance and repeatable performance, both for the engineers and the data scientists who are actually studying the models using machine learning algorithms to extract knowledge out of this data. We'll give them some example, but also then to ensure reliable operations, because at the end of the day, we'll need to have actions taken in a timely manner out of this data while they flow from the rolling stock, and this system must work as clockwork. So it's a pretty complex architecture. We learned actually during the project with Trenitalia, we're using the same architecture footprint for similar systems in the future. Now, Paolo, just getting back to one point that I think it's actually, at least from my point of view, is probably the most fascinating. We're seeing a huge transformation planned maintenance, right? So this notion of not using kilometers anymore, but going more granular, like you were talking about the opening and closing cycles for doors. Can you give us, intuitively, I think it's pretty easy to understand. It's more relevant, it's more connected to the physical reality. But can you give a sense of how this is working, or how this is going to work in the future? Because at the end, you don't dismount, take out the door to maintain the door, right?
No, yes, absolutely. Starting from what happens now, that each train have a maintenance plan, and there are some deadline, time, or kilometer deadline, and at this deadline are associated a list of things to do on trains, of course. Then this activity now are grouped on more on the logistic base, more. So the interest is, oh, I have not to stop the train every day. And this is clear because the train is made to transport passengers or goods and not to be maintained, of course. But actually this choice was made 10, 20 years ago, not knowing well what will be happening in the future. And then now we want to reverse the concept. And then, okay, I want to know the truth. How he is aware of the individual components, and how was the limits for the aware of this individual component. That is, now there was the operational desk in Trenitalia, the fleet manager, that scheduled the fleet in a quasi-static base, and his main occupation is to make the train respect the kilometer deadline. And then that is, okay, I have 1,000 kilometers, and then I can go to Milan from Rome and coming back. Not more, because otherwise this is what happens. And he has a dashboard in which there is, for each train, how many kilometers it remains. You know? In the future, this will be very more complicated, because for each train, it will be some 100 of these indicators that are to be expiring or not. Then activity will be, the activity of the maintenance plan that I mentioned before, they are exploded. They will be the same, of course, especially in the first stage. But they will be grouped dynamically, depending on how this indicator evolves, with some interesting possibility that up to now is not exploited. If I have the train that is expiring 4 doors, 4 cycles of the doors, then I can run this train, but on a path with not so many opening and cycle doors. And then I can increase the life of the whole train, while in the previous paradigm, I was constrained to stop the train. Also, for instance, we are measuring wearing on the wheels. Sometimes trains make more wheel on the left than on the side. And then the wear of the wheel is asymmetrical. Then with this, we can preview this asymmetrical wearing, and then to optimize the scheduling in such a way we can bias the wearing on the wheel in these two dimensions. Then, of course, at the end, we need a more sophisticated scheduling system that take into charge the time schedule of the fleet, of the commercial operation, of course, the availability of spare parts, the availability of shops position, no? And the availability also of manpower, just to make a dynamic scaling, a dynamic grouping of maintenance activity just to optimize the money at the end, no? Because we are here not for philosophy, but for business. And for this, we need many algorithms to predict events and maintenance. But many people talk about prediction. But Francesco, could you make some example of this?
Absolutely. By the way, I didn't remember that in 2001 Space Odyssey there was that scene. It was so funny because that had been sort of my life for the last 3 years, talking about predictive maintenance, and that was one of my favorite movies as well. Anyway, what we found is that, one thing I find interesting, we call our SAP solution Predictive Maintenance and Service. In the video, I think, unless I'm not wrong, the word predictive is never mentioned, right?
No.
Yeah. So we actually decided to label this project dynamic maintenance, not predictive. Predictive is pretty tricky when we talk about complex assets. So let me say that straight. If you think about predictive as in the movie, being able to say 3 weeks from now that specific wheel of the train will fail, we are not able to do that. We never tried, we never succeeded in achieving anything close to that. Why is that? Very simple. These assets are critical, very expensive, livestock, people depend on that. They tend to be over-maintained, if you want. But in order to do this kind of predictions, you need to have many failures of the same type. And we don't have those, as simple as that. So we had somehow, when we started to work in reality, we had to retune and refocus our efforts from a predictive perspective. And what we found is that we can actually use predictive models in a way that's extremely powerful, not so much to predict, that part will fail 3 hours and a half from now, but to see how components behave and how their health can be scored. Like, for example, one of the most impressive examples with the 464 fleet, the 700 locomotives Paolo was talking before, those machines have batteries on board. Now, we found that using exactly the same kind of unsupervised algorithms, machine learning algorithms that Professor Kaplan was mentioning before, we can somehow define patterns of behaviors, like patterns of faces of cats. But in this case are the behavior of tension and current for these batteries while they operate, or while they sit idle, or while they are being recharging. And using these algorithms, we actually found what is basically a well-behaving battery and what is something different, and measuring the distance between well-behaving batteries and the specific battery number 27, we're able to rank the batteries. Now, does this mean that the batteries at the bottom of the rank are going to fail tomorrow? No, it doesn't. But what it means is that we were able to say, okay, the top 50%, instead of checking these batteries every 2 months, we're going to start to check them every year, as long as they're in that part of the ranking. The bottom, maybe instead of 2 months, we start to check them every month, because that would actually reduce the risk of failure. It is not an absolute prediction, but actually what we're seeing already is a massive increase in reliability and an even larger saving, which is, by the way, significantly higher than the 10% mentioned in the video. So that's a very concrete application of machine learning and predictive techniques for critical assets. Now, Paolo, let's wrap up this session. We are at the end of time. Just want to maybe, if you can give us one thought about one thing I always find very impressive. So Trenitalia is a company that operates in a very old economy business, state-owned company, Southern Europe, yet you're here representing what I can say is the most innovative project SAP has in the area of IoT in the world. How do you guys do that? How this company so unintuitively turned out to be so innovative?
But this, as I said before, it was a very big renovation, also of peoples, and also of people in the top positions. And this gives a very impressive change of culture. But also we see that railways is an old-style economy because it was a big time of return of investment of 10 of years, not like a new economy. But it was a big technology content inside our trains, and especially the new one, like TR1000 we speak before, and also that we see that in the future it will be a big convergence between sectors. The sector of mobility is now approaching a very good revolution because of driverless car, for instance. Then we need to stay on the path of this revolution. I see a future in which probably private car will be reduced, and the more there are automatic taxis that take the people from home and carry to the station, then take high-speed train, and then every kind of transport mode make his piece of part in a very collaborative ways. But for this we have to share the best practices that we have in the world. And we have this support from our CEO, of course. And Francesco, just to end, what's the lesson you learn collaborating with us? What do you think to do in the future?
Yeah, so just 2 words. Maybe some of you guys in the audience know that SAP has been working around this notion of predictive maintenance for more than 3 years now, with several customers in Western Europe and North America mainly. This project is arguably the most important we have up to now. We've been learning a lot because some of the algorithms that we've developed together actually demonstrated already to be valuable for other categories of assets, other contexts. Just, if I can be very straightforward and advertise a couple of things, there's a new solution coming out from Predictive Maintenance shortly from SAP that Oliver Meinke, a colleague of mine, will present this afternoon, I think at 3 p.m., if I remember. If you think about what you heard now in the keynote, because the Trenitalia project has been a big source of inspiration for that solution. You can also, of course, if you're interested, Paolo and I will present more into the details this project tomorrow. Also tomorrow, so you can also get more insight in some of the trickier aspects tomorrow. But yeah, it's been a great journey. We're not there yet. One thing I want to make very clear, the project is underway. We're seeing results, but the journey is on, and maybe we'll be here back in the future to give you more update on this one.
Thank you very much, Francesco.
Thank you very much.
Paolo, thank you.